This is Mr. Moray coming to you with a video recapping the factoring trinomials sheet. In other words, I posted this on the class Google Doc, and when I did, I gave it this name right here. So we call this factoring when I think I may have said something like that. So this is the answer to that worksheet. Okay. So in this video, I'm going to do a quick rundown of my answers. And hopefully this will help you, and you got pretty much what I got as well. Okay. So in the first one, again, the idea is to factor when a is greater than 1. So I know that to get 3p, it's going to have to be 3p and p. Then I'm going to think about how could I get 5? Well, the only way to get 5 would be 5 and 1. So I'm going to make this one my -5 and this one my +1. And when I do that, I'll get 3p squared plus 3p minus 5p. That's -2p minus 5. Right? Then what I'll do here is I'm going to do, again, it's got to be a 2. Only one way to get 2n squared is to do this. Now, the only way to get -9 would be that I'd have to have a +3 and a -3. Now, this is usually a setup for a difference of squares, right? N plus something, n minus the same thing. Except here, one of them is a 2n and one of them is a 1n. Okay, and so what I know is that the 2n has to get multiplied by the 3 to make 6n. So that when this n gets multiplied by the -3, it pulls it back down to +3n. Okay? So you can see that there's a common thing here, right? The more prime numbers you have, the more straightforward the factoring becomes, right? Because the prime numbers restrict the possibilities. Here it's going to get a little bit more fun because I've got 4 could be broken down as 4 and 1 or 2 and 2. And what I know now is both of them are going to be negative because I've got to add to a negative and multiply to a positive. And as it turns out, it's going to be 2 and 2. -6n, -8n, 4, 3n squared. Okay, here, 12 makes it look pretty challenging, right? But these have to be a 5n and an n because it's the only way that you're going to get 5n squared. Make sure I'm moving the right thing here. And now I want to get 12. So 12 is a little bit more challenging because 12, there's a few different ways you could get that, right? And you always want to break down those possibilities. So we have 12 and 1, or 1 and 12. We have 6 and 2, or 2 and 6. We have 4 and 3, or 3 and 4. And that is basically it. Okay, because then we wrap back around to 4. So, okay. I need to add to 19. So I have a sentence that they both have to be positive because they're going to add to a positive in the end. And they're going to also multiply to a positive, right? And two positive numbers, when you add them, you get a positive. And when you multiply them, you get a positive. But which one is it? Well, I'm going to use some intuition here. So I noticed that 5 times 3 is 15. So I'll set my 3 here. And then 15 plus 4 is 19, so I'll set my 4 there. And this is just basically process elimination. But notice, there's no tricks here. I'm not teaching you to set up some kind of fancy puzzle or pull a rabbit out of a hat. We're just using logic of what would happen when we're actually going to go ahead and box this out, right? Because when I box this out, I'm going to have to put my 5n here and my 4 here. And set it like this, or vice versa, right? I could have set it up the other way around. Okay, and I know this is what's going to get me my 5n squared. This will always get me my number, 12. And then this, 4n, and this will be my 15n, right? So thinking about how distribution works, and the box is just essentially a picture of what the distribution looks like. Okay, moving on to number 5. Again, you can see this one's pretty good, right? This one's actually really straightforward, because you know this has got to be 2v and v. That's the only way to make 2v squared. And the only way to make 5 is 5 and 1. It's just a matter of where you put it. and I know they're both positive based on this positive here. Here again, similar thing. The only way to get 2n squared is 2n and n. And then I'll set my 2 here and my 1 here. So I get 4n plus n plus 2. All right, here I start with my 7n. So I call it A actually, 7a and a. And now I need 28. And so 28 would be 28 and 1, 14 and 2. 3 doesn't go into it, 7 and 4. 5 doesn't go, 6 doesn't go, 7 I'm back around. Perfect. So now I got to play around with some possibilities. I notice I've got a 53 here, and I've got a positive and a positive, so I'm going to be looking for them to both be positive, which is nice because you're not playing around with different signs. I think that was definitely a pattern here. Now one of them is going to get multiplied by 7, so that's something to take into account. So I'm probably not going to be 28 and 1, because if I put the 28 here, we get way over. But if I put the 28 here, we're never going to get as big as 53. So 28 and 1 is out. 7 and 4 is most intriguing to me. So I'm going to put my 7 here so I get 49a when I do this part of it. I'm going to put my 4 here so I get 4a. And then I'll have 49a plus 4a is 53a. Okay, this one's going to be a challenge. This is the biggest challenge because 9 could be 9 and 1, or it could also be 3 and 3. So essentially the most complicating factors here are the number of possibilities that you'd have to consider. Okay? And so the more different factors of the A value and the more different factor combinations of the C value, the more difficult it's going to be because the more things you have to test. So I might have to just try 3 and 3 and see what happens, right? So if this is 3k and this is 3k, we could get 9k squared. That's possible. Okay, so let's see what happens. So let's say this was 7 and this was 3. Let's check real quick. This would be 21. That would be 30. Rearranging it won't affect anything. That's the good thing about this, is flipping won't matter. What if I did 21 and 1? This would be 63, 66. So perfect. Perfect. So I got lucky. And if this didn't work, I would try 9 and 1. I didn't start with 9 and 1 because usually that's not the combination that's right. But you know what? Never forget the 1 with the 1 in it, because that combination, like we've seen before, happens more often than you think. All right, so I hope you found this video to be helpful. Please make sure at this point you're caught up with the homework, you understand what I did here, and that you're being able to stay up to date with all the lessons. I know I've definitely thrown a lot at you guys this week, so I'm going to be thinking about that in the lesson for today. All right, but keep it up. Think about what you might want to ask me at our upcoming Google Hangout on Friday. And remember, you can do it. All right, thanks for tuning in. Don't forget to love math, and have a wonderful day.